let's dive into the world of design patterns. Now, these are basically a set of powerful, reusable solutions for the kinds of problems we face all the time when writing software. If you've ever felt like your own code is getting a little too complex, well, these patterns might just be the escape hatch you're looking for.
You know that feeling, right? You're deep into a project, and you get this weird sense of déjà vu, that feeling that you're solving the exact same problem you already figured out last month, just in a slightly different way. It's like you're constantly reinventing the wheel.
Well, it turns out you are not alone in feeling that way. This is such a common thing in software development that the community came up with a formal solution: design patterns. Think of them as blueprints, proven, tested solutions to these recurring problems, so we can all build on the collective wisdom of developers who've been there before.
So here's what we're going to cover. First, we'll talk about why these blueprints are so important. Then, we'll get into two big categories: creational patterns, which are all about creating objects, and structural patterns, which deal with how you piece objects together. And finally, we'll wrap it all up so you can start building your own design pattern toolbox.
So what's the big deal with these patterns anyway? Well, beyond just giving you a solution, they create a shared language, a kind of shorthand for developers. When you can say, hey, let's use a singleton for that, the whole team is instantly on the same page. It makes talking about complex designs incredibly fast and efficient.
You know, every official design pattern really has 4 key parts. You've got the name, that's the handle you grab onto. Then there's the problem, which tells you when and why you'd even use it. The solution gives you the abstract design, the blueprint itself, and maybe most importantly, the consequences. Because let's be real, in coding, there are always trade-offs.
All right, let's dive into our first group, creational patterns. These are all about mastering the art of creating objects. When you use these, you can make your system way more flexible because you're separating the code from the specific types of objects it needs to create. Okay, here's a classic situation. Imagine you need one and only one shared resource for your entire application. A good example is a connection pool for a database or maybe a single logger. How do you stop other developers, or even yourself, from accidentally creating extra copies, which could lead to total chaos?
The answer to that problem is the singleton pattern. Its job is simple, but it's absolutely critical. It guarantees that a class has one and only one instance, and it gives everyone a single global way to access it.
So how does it actually work? Well, it's a pretty clever 3-step trick. First, you make the constructor private. That completely stops anyone from just creating a new instance. Second, the class itself holds its own single private static instance. And finally, you provide a public method, usually called something like getInstance, that just returns that one single shared instance. It's simple and it's incredibly effective.
Okay, next challenge. What if your application needs to create an object, but you don't actually know the exact class you need until the program is running? Think about needing a database connector. Should it be for MySQL or Postgres or something else? The user might choose that from a config file, so you can't hard code it.
This is the perfect job for the factory pattern. Instead of your code calling a specific constructor, you just ask a factory to build the object for you. This is huge because it completely hides the creation logic from the client code. It makes your system way more flexible and easier to add new types later.
So here's the magic behind it. Your code, the client, only knows about a general interface, like, say, database connector. It asks the factory for a connector, and the factory looks at the configuration and decides whether to hand back a MySQL connector or a Postgres connector. Your client gets the object it needs and can get to work, totally oblivious to the nitty-gritty details.
So, we've talked about controlling how objects are born, but what about how they live and work together? That brings us to our next category, structural patterns. These are all about how you compose objects and classes into larger, more complex structures, making your architecture flexible and stable. Oh, this is a situation I think we've all run into. You find this amazing new library, or you have to work with some old legacy code. It's perfect for the job, but there's one big problem. Its interface is completely different from what the rest of your system expects. The method names are all wrong, the parameters don't line up, they just don't speak the same language. The solution here is the adapter pattern, and it works exactly like it sounds. You know, like a power adapter lets you plug your laptop into a weird outlet in another country. This pattern does the same thing for your code. It's a special object that acts as a bridge or a translator between two incompatible interfaces. Let me break that down. Let's say your application is designed to call a method named request, but this legacy component you have only provides a method called specific request. The adapter sits right in the middle. Your app calls request on the adapter. The adapter then turns around and calls specific request on the legacy component, passing everything along. It's a really clean and elegant way to solve that incompatibility problem.
So, what does all this really mean for you day to day? Well, creational and structural patterns aren't just some abstract academic ideas. They are real, practical tools for your developer toolbox, and they are designed to help you write code that's cleaner, more flexible, and way easier to maintain.
So let's recap real quick. The Singleton, that's your go-to when you need one and only one instance of something. The Factory, perfect for when you need to create different but related objects on the fly. And the Adapter, an absolute lifesaver for making two components play nicely together when they weren't designed to. It's all about building systems that can adapt and grow. Now that we've gone through these amazing blueprints, I have a question for you. Which one of these are you going to use to tackle your next coding problem? Think about the challenges you're facing in your projects right now. Is there a spot where a Singleton, a Factory, or an Adapter could make your life a whole lot easier? Once you start thinking about your code in terms of these patterns, you'll be amazed at how much clarity it brings to your designs. If this was helpful, please don't forget to like, share, and subscribe for more deep dives into building better software. Thanks so much for watching.